Hi all, welcome back to my channel. In the previous video, we have seen the internal architecture of 8086. That means what we are seeing inside this microprocessor. Okay, in today's lecture, we are going to see the pin diagram of 8086. As you already know, it is the first 16-bit microprocessor available with a 40-pin dual-in package. See the figure. There are totally 40 pins, out of which first 20 pins are on the left side, that is from 1 to 20, and the remaining 20 pins, that is 21 to 40, is on the right side. Let's see the functions of each pin in detail. Firstly, we will discuss about the power supply signal and ground signal. So here you can see in the figure, pin number 1 and 20 is connected to ground and pin number 40 is connected to our VCC supply. Next, our microprocessor need a clock signal for the proper timing of processor. That clock signal is connected to the pin number 19. Next is the address and data bus. As we already know, our 8086 has 16-bit data bus. That means its data can be represented using 16 bits from D0 to D15. And also it has a 20-bit address bus. That means its address can be represented using a 20-bit, that is from A0 to A19. So, if we use this address bus and data bus separately, we need around 35 pins to represent this address and data bus. So, here we use a multiplexed address and data bus. That means the same bus we can use to send address and the same bus we can use for data also. So here the 15 bits of data bus and the first 15 bits of address bus are multiplexed, which can be represented as AD0 to AD15. Where AD0 to AD14 are connected from pin number 16 to pin number 2 and the AD15 is connected to pin number 39. The remaining 4 bits of address bus, that is A16, A17, A18, A19 are multiplexed with the status signal S3, S4, S5 and is connected to the pin number 38, 37, 36 and 35 that you can see in the figure. That means during the first clock cycle it will transmit the address and the next clock cycle it will transmit the status signal. The status signal S3 and S4 is used to select the segment. That means if the value of S3 and S4 is 0, 0, then it will select extra segment. If the value is 0, 1, then it will select stack segment. And if the value is 1, 0, then it will select the code segment. And if the value is 1, 1, that will indicate the data segment. Then the remaining two, that is S5, which is used to indicate interrupt flag, and the S6 is used to indicate the status of master flag. Then you can see the pin number 34, which is connected to BHE bar S7. This bar indicates active low signal. That means the signal will be activated only when the value is low, that is 0. BHE means bus high enable. It is used with the S7 signal. The purpose of this signal is to indicate the transfer of data. That means if the value of BHE bar S7 is 0, 0, it indicates that all the 16 bits is to be transmitted. If the value is 0, 1, which means that upper byte should be transmitted, that is upper 8 bits. If the value is 1, 0, that means lower byte, that is lower 8 bits should be transmitted. If the value is 1, 1, it won't transmit anything, it will stay in the ideal state. Next pin number 33, minimum or maximum bar. That is very important pin. According to the value of this pin, we can draw the two pin diagram. One is in the maximum mode, another is in the minimum mode. All the pins except pin number 24 to 31 are common for both the modes. If the value given to this pin is 0, then it will work as a maximum mode. For the maximum mode, all the given pins are used. If the value to this pin number 33 is 1, then it will work in the minimum mode. So instead of using these signals, it will use the signals given in the right side. Minimum mode means a single processor configuration. That means only one processor is there. Maximum mode means multi-processor configuration. That means more than one processor or multi-processors are used. Then from pin number 24 to 31, we have a maximum mode or minimum mode signal. Firstly, we will discuss about the maximum mode signal. After, we will discuss about the minimum mode signal. Next is the pin number 32, which is connected to RD bar, which indicates the read operation. That means whenever the value given to this pin is 0, it will read the signal. Pin number 21 that you can see in the figure, which is connected to reset signal. Reset means which will reset the complete operation. That whatever it is doing, it will terminate and will restart. Pin number 22 is connected with the ready signal. That indicates that the device is ready to transfer the data. Pin number 23 is connected with the test bar signal. If the value of this test signal is 0, then it will continue its execution, and whenever this value is high, it will go to the ideal state. Then the maximum mode signal, pin number 24 and 25, that is connected with the QS1 and QS0. These both signals are used to indicate the status of queue. That means if the value of QS0 and QS1 is 0, 0, there is no operation will be performed. If the value is 0, 1, first byte of the instruction Q will be transferred. If the value is 1, 0, it will empty the queue. And if the value is 1, 1, subsequent byte of the instruction Q will be transferred. And next is pin number 26, 27, 28, which are connected to the status signals S0 bar, S1 bar and S2 bar, which indicates the status of the operation. Depending upon its values S0 bar, S1 bar and S2 bar, the following operations are performed. That is given in the figure. Pin number 29, which is connected to low bar signal. It is an active low signal. When this signal is active, the other processors won't get the control of the system bus. Next is pin number 30 and 31, which is connected to RQ bar, GT1 bar and RQ bar, GT0 bar. These are request or grant signal, which is used by other processors to ask the CPU to release the system bus. These all are about the maximum mode signal. Now we will discuss the minimum mode signals. Whenever the value given to the pin number 33 is 1, it will work in the minimum mode. So in the minimum mode, pin number 24 is connected to INTA bar. INTA bar indicates interrupt acknowledgement signal. It is just a signal to indicate that the interrupt has been received. Next, pin number 25, which is connected to ALE signal, address latch enabled signal. We know that we are using a multiplexed address and data bus. So at a time it can transmit either address or data. This address latch enabled signal is used to differentiate that whether it is transferring address or data. When the value of ALE signal is high, that indicates that address is transferring through the bus. If the value is low, means that data is transferring through the bus. Pin number 26 is the DEN bar, that is data enabled pin. This is to separate the data from the address or data bus. Next we will see pin number 27, which is connected to DT bar R bar. That will indicate whether the data is transmitting or receiving. If the value is 1, it will indicate the transmission of data, and if the value is 0, that means it is receiving the data. Then pin number 28, which is connected to M bar IO bar. That is to indicate whether it is a memory operation or IO operation. If the value is 1, means it is a memory operation, and if the value is 0, means it is a IO operation. Next is pin number 29, which is WR bar signal, which is used to indicate the write operation. Whenever the value is 0, it will write data to the memory. Next pin, that is 31, which is connected to hold signal. This is to indicate the processor that some other masters are requesting the address or data bus. So the next pins, that is pin number 17 and 18, are for the interrupt. 17 is connected to NMI. NMI means non-maskable interrupt. That is, whenever this interrupt comes, it cannot be ignored by the processor. This NMI is an high priority interrupt. The pin number 18, INTR, interrupt request signal, which is to indicate whether the process is interrupted or not.